This slide explains why the finite population correction, or the FPC, can be left off of the formula when the population is 20 times larger than the sample. As the sample size and population size get further apart, the FPC gets closer and closer to 1. And when the population is 20 times larger than the sample, the FPC is so close to 1 that it doesn't really affect the final answer, which means that the FPC can just be dropped off of the formula. When you multiply something by 1, it doesn't change the answer. So when the population is 20 times larger than the sample, the FPC is so close to 1 that you're basically multiplying this part of the formula by 1. And multiplying something by 1 doesn't change the answer. That's why the FPC can be left off when the population is 20 times larger than the sample. So if the population is at least 20 times larger than the sample, it's possible to get a roughly correct answer using a shortened version of the formula that doesn't include the FPC. So we're going to go through some examples in which the population is 20 times larger than the sample, and we're going to show how we can use this shortened formula and still get a roughly correct answer. Here's our first example. We have the same scenario that we've been looking at before, in which a person is calculating the mean height of every possible sample of 10 people. But in this example, the population is 20 times larger than the sample. The population has 200 people, and we're dealing with a sample size of 10. So what we're going to do is we're going to use both formulas, the formula that includes the FPC and the formula that doesn't include the FPC. We're going to see how they both give us about the same answer. So here's the shortened formula without the FPC, and here's the longer formula with the FPC. The shortened formula gives us an answer of 1.42 for the standard error, and the long formula with the FPC gives us an answer of 1.39. Technically, this answer is correct, but by using the shortened formula, we got an answer that was pretty close to correct. 1.42 was pretty close to 1.39. So this slide is demonstrating how you can use the shortened formula for the standard error and get a roughly correct answer when the population is 20 times larger than the sample. Now we'll look at an example in which the population is 100 times larger than the sample. This is the same scenario we've been looking at, except now the population has 1,000 people. We're going to use both formulas, and we'll still see that they give us about the same answer. So this time, the shortened formula gave us an answer of 1.42, and the longer formula gave us an answer of 1.41. So this time, the two answers are even closer together. That's because the population and sample sizes are even further apart. The further apart the population and sample sizes are, the more accurate of an answer you'll get with a shortened formula. So if the population is 100 times larger than the sample, you'll get a highly correct answer using the shortened formula. So overall, as the population size and sample size get further apart, the FPC gets closer and closer to 1. And if the population is at least 20 times larger than the sample, you can leave off the FPC and still get a fairly correct answer for the standard error using a shortened formula. The reason why you can leave off the FPC and still get a fairly correct answer is because when the population is 20 times larger than the sample, the FPC is pretty close to 1, and it doesn't affect the final answer by very much. We'll skip over this example. Let's now go into some other types of problems. We're going to look at some sampling distribution probability questions. We're going to go through some examples in which we find the probability of getting a sample with a certain sample mean. This is our first example. We have a population of 4 people, such as a family of 4 people, and these are their 4 heights. And what we want to know is the probability of randomly selecting 2 people from this population and getting a sample with a sample mean that's below 4.7.